Dear students, welcome back. In this session now we are going to discuss about reversing switch. Okay, normally the switch, in normal switches, the current is turned on and off by means of a switch. That means if we on the switch, the circuit is closed. For example, if you can take a circuit, okay, if you on the switch, the circuit is going to close. Okay, then the current flows. Okay, if the switch is off and then this circuit is open and the current will not flow. Okay, that is the main function of a switch. So the current is turned on and off by means of a switch. But this reversing switch, actually it is a device. Okay, normally technically and in the electronics, this reversing switch is called as double pole double throw type of switch, and which is having 6 connections. But polarity reversal is a very common usage of reversing switch. So for that only we are using this reversing switch in the circuits of physiotherapy equipments. Okay, so then what happens, because of this polarity reversal is a very common usage, so these DP-DT switches, that is double pole double throw type of switches, will have some variations which are internally wired and specifically for polarity reversal, and these are modified into having 4 terminals rather than 6 terminals, and 2 terminals for input and 2 terminals for output. So finally, in the reversing switch, what we are using is having 4 terminals. Okay? Yes. So when connected to a battery or the direct current source, the 4-way switch selects from either normal current or reversed polarity. For any type of ways of source, it can be able to use. That is the main function of this reversing switch. Okay, so now we will see the working of a reversing switch. Okay, so this device is commonly employed or placed in direct current circuits for reversing the direction of the current supplied to the patient. Okay, so why it is going to use means, one reason is for reversing the polarity, and this can minimize chemical burns also. Okay, and now we will see how the switch is designed. So this is the actually this is the switch, this part is switch. Okay, yes, this reversing switch has 2 semicircular metal strips. So these are the 2 semicircular metal strips which are joined together, okay, with the convex surfaces towards each other. The convex surfaces of this semicircular metal strips are faced each other, and but these 2 strips are separated by an insulating material. Okay, and 4 equidistant contacts are arranged so that one touches each end of the strip. That means it is having equidistant contacts. So here this one A, B, C and D. Okay, these are the equidistant contacts of this switch. Okay, and each end of the each strip. Okay, so that means for each metal semicircular strip will have two ends. These are equidistant ends of the switch. Okay, so these contacts are fixed, but the strips can be rotated. So here if you can see the contacts, that means this A, B, C and D contacts are fixed, but the strips are able to rotate. Okay, through a quarter of a circle, and by a turning a knob. Okay, so this is a normal type. These are the switches, one of the type of reversing switch we can see in the markets. So here we can use it for reversing the polarity by using this knob. So this is the knob which can rotate the strips, inside the circuit. Okay, so the rotation of this strips is only a quarter of a circle. Okay, now two opposite ends A and B are connected. Two opposite ends A and B are connected to the source of current. A and B are connected to the source of current. Okay, and now the two opposite contacts, that is C and D, the other two opposite contacts C and D, to the external circuit. So C and D, so here C and D, which are connected to the external circuit. So normally this external circuit is to the patient. Okay, yes. So this is the connections of this reversing switch. If you see the course of the electron flow, so normally from negative terminal, so it will flow from main source to A, and then it reaches to C, and then it reaches to the external circuit, that is patient, and from here the electrons again reverse. So here you can find any source. After that it reaches to Y and D, B, and this terminal. This one is the flow of electrons. So what happens if you change? Okay, if you change or if you rotate the strips, and then here if you can see the connections are changed now. Okay, the strips have been rotated through a quarter of a circle. In this picture again you can see how the electrons will pass. So now after rotating, the reversal of this strips are going to take place, and the connections for this one is A to D and C to B. So B to C is the connections now after rotating the knob. So again the current flows from main source to the A, and then it goes to D. From D it to the patient circuit, and it is reversed to the B, that is X, which reaches to C and B finally. So what is happening? So that the flow of current now it becomes reversed. Okay, yes. So this is the functioning or working of this reversing switch. Okay, so if a reversing switch is included in a circuit in which a one-way reading milliampere meter is used, and the latter must be placed before the reversing switch. Okay, that is the milliampere meter should be placed before the reversing a switch. Okay, so this is the working of the reversing switch. In the next session we are going to discuss about the production of direct current for the treatment of patients from the alternating current mains. Okay, thank you.